Okay, everybody, this is our first day one of our distance learning. Doing the notes for transformations, day number 6, rotations on the coordinate plane. I'm going to make this as quick as possible for you guys so you have time to practice your assignment. I do just want to let you know, anytime I start a practice problem, please pause the video and see if you can do it on your own, and then restart it to see how you did on it as far as the answers go. I'm just going to go straight through. I'll try to remind you from time to time to stop the video and try it on your own. Okay, today's topic, we're going on to our third transformation, which is rotations. You guys will remember we've already done reflections, which is our lowercase r followed by the line I'd like you to reflect over. And then we did translations, which is your slides. And as you remember, there's 3 different ways I could represent a translation. I could do function notation, which in this case would tell me, hey, go to the right 2, down 3. I could do vector notation, go to the left 4, up 6. Or I could do our other notation, which is our capital T. Don't go anywhere on the X and go up 2. All right, so reflections and translations. With rotations, you'll remember I mentioned in class when we did reflections, we do lowercase r specifically for reflections, because for rotations, we have an uppercase R. And you will also see subscripts with the uppercase R. You may see the following. Right? If I see the first number I see there is a 0, which says, hey, we are going to rotate around the origin 90 degrees. Okay? So usually, just for now anyway, we're not going to get too crazy, but usually we'll rotate around the origin only. Could we rotate around any other random point? Sure, but for now, just worry about rotating around the origin. Now, the 90 degrees is key. If that is a positive 90 degrees, we are going to rotate counterclockwise. All right, so if you think of a clock, we're going to rotate in this direction. Okay, now, if I had negative 90 degrees, it would be in a clockwise direction. All right, so that's one way you could see the notation for a rotation. The other way is without where we're going to rotate around. So you'll just see this, which means the exact same thing we just talked about up here. Okay, we assume we rotate around the origin if there's nothing there for us. But the big thing I need you guys to remember is positive 90 is counterclockwise versus negative 90, which is we're going to rotate in a clockwise direction. Okay. So for the first example here, go ahead, pause the video, graph triangle DEF. When you're ready, come on back. Okay, we are asked to rotate it 90 degrees counterclockwise about the origin. All right, I can't physically rotate my screen here, but what I did was I cut out a duplicate of triangle EFD. And we are actually going to rotate by you physically turning your paper. So what I need you to do right now, put 2 hands on your packet. And what we're going to do, we are going to turn 90 degrees counterclockwise. So please think about a clock. When you guys go counterclockwise, remember we are going in this direction. So you should be doing a quarter turn to the left, which I will do right now on my duplicate copy. So everyone go ahead, a quarter turn to the left. All right, what you're looking at right now is a new Y and X axis. So what I want you to do is keep your paper right where it is right now, that quarter turn to the left of 90 degrees. And I want you to tell me, what's the new point D? All right, what's the new point D? And if you see, let's see, I go over to the left, 1, 2, 3, and up 2. So D prime now is going to be -3, 2. All right, and do the same thing for F and E right now. Look at your quarter turn paper, write the new coordinates down of F prime and E prime. And hopefully we're getting F prime to be -6, +2, and E prime to be -6, -1. Now go back, turn your paper back to the original place you were at, and go ahead and graph triangle D prime, E prime, F prime right now. And there it is. Okay, D prime, F prime, E prime. All right, go back to my copy here. I'll go back to the original. Okay, again, if I wanted to go 180 degrees, it's just turning your paper upside down, 2/4 turns, and then 270 would be 3/4 turns. All right, again, rotate it, write down the coordinates, then go back to your original and graph them. All right. Now, I know some of you may not like what I just shown as far as physically rotating your paper. There are rotation rules if you choose to memorize them. I'm not going to be forcing you guys to memorize it. I like turning the paper. But if you do want to know the rules, I put them in your packet right there. So for example, if you ever needed to rotate anything 90 degrees counterclockwise, there's the rule. You take your coordinate, flip them, and change the one on the Y. I just think it's a lot to remember. I've given you guys some reflection rules for through y equals x and y equals -x. I just think it's a lot to remember, so that's why I like turning the paper. But if you want to memorize those three as well, feel free. All right, and also just keep in mind that anytime that you rotate 90 degrees is the same as rotating negative 270 in a clockwise direction. And if you rotate 270, that's the same as rotating -90. Okay? So there's the quick run through rotations. What I want to do now is just go over every transformation we've done so far on one problem. All right, so I'll give you a second right now. Pause the video, go ahead, graph triangle ABC, and we'll talk. Okay, first part, graph triangle ABC through a reflection in the x-axis, okay, on the x-axis. So if you want to pause the video and try that on your own, go right ahead. I'm going to write the coordinates up here. A prime should be 2, -1, B prime, 6, -4, and C prime, 8, -1. Okay, I'm not going to graph it. I'm just going to go through it, but go ahead, pause the video, go ahead and graph it. Next one, A double prime, B double prime, C double prime. Now it's a translation, you'll notice. This is our other notation right here. And if I look at the subscripts, I'm going to go left 6, down 2. Yep. Okay, so I'll write, you guys can stop the video, try to get those coordinates on your own. Go ahead, graph it, see how you do. A double prime, 4, -4, -3. B double prime, I have 0, -6. And C double prime, I have 2, -3. All right, so make sure those coordinates are correct and graphed correctly. Next up, C double prime. I'm going to take the double prime triangle I just had in part B, and I'm going to rotate it 90 degrees. Oh, buddy, here you go. Hey, pay attention. Clockwise. So now you're taking your paper, 2 hands, rotating in a 1/4 turn to the right. All right, to the right. Or again, go back and memorize your rules. And a 90 degrees clockwise rotation is the same as rotating it 270 degrees, positive 270 and counterclockwise. So you can remember your rules, rotate your paper, stop the video, and write down the coordinates and graph it. All right. Coming back, you should have A triple prime as -3, 4. You should have B triple prime as -6, 0. And you should have C triple prime as -3, -2. Okay. So make sure all that's graphed. And then we got a part D here, A quadruple. How about that? Quadruple. Now we're getting real. But here's the thing, read the problem. We're doing the quadruple prime, the image of triangle ABC. So I'm going to go all the way back to my original coordinates, and I'm going to reflect it over the line y equals 2. Think about it right now before I show you what type of line is y equals any number. Y equals any number. Think about what type of line I'm going to reflect over before I write it down. All right? You are going to reflect over a horizontal line, y equals -2. All right, so we're going to take all our coordinates from the original, which I have graphed up here already. So we're going to go, I'll start with A, 1, 2, 3 units away, 1, 2, 3 units away. All right, there is A quadruple prime, like how I did that, just write it to the fourth. 1, 2, from B now, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 on the other side. And then same thing with C. 1, 2, 3 away, 1, 2, 3 away. All right, and there is your quadruple prime. Now we just have to write the coordinates. I have 2, -5. I have 6, -8. And I have 8, -5. Okay. Everybody good? Now, if you're getting these coordinates wrong, the quadruple prime, make sure you guys start counting from the origin. I see a lot of years that kids start counting from the line of reflection instead. So if you had -3 as a couple of your y coordinates here for A and C, that's because you're starting to count from the line of reflection. You had one job, start from the origin. Okay? So that goes through basically everything we've done in the transformation unit. All right, second half of today's notes is taking a two-dimensional figure and rotating it around a line to form a three-dimensional figure. All right, so here's what the deal is here. I have a part of a triangle here on this first example, and I'm going to rotate it around line L. So line L stays right where it is, and I'm just going to rotate the entire triangle around line L. What do I end up with as a three-dimensional object? So think about that real quick. I'll show an actual example of doing this. Again, I'm going to take line L right where it is. I'm going to start rotating this triangle around and around and around and around. All right, so just to show you what I'm doing here, here's my triangle. Now I'm going to get this. There we go. Now let's start rotating it around and around and around that line there, just similar to what we're doing in the notes. And you'll start seeing that it is going to start forming a three-dimensional cone. All right, there it is. All right, after I rotate it 43, 45 times around that line. All right, so again, I start with my triangle. Here's the line right here that I'm rotating it around. And as you can see, it will start forming a cone. Okay. All right, let's go to the square, or it could be a rectangle as well. Again, I'm keeping line L right where it is and rotating it around. What do you think that three-dimensional object would be? Again, we can go try it out. Let's rotate a rectangle around now. Here we go. Again, we're going to keep this line right where it is. And let's rotate. As I rotate around that line 23, 27, 34 times, you will start to see a three-dimensional object that we call a cylinder. Okay, again, rotate it around that line. That is starting to be a cylinder. All right, yeah, that looks great. Cylinder, all right, and then finally, how about a circle? What if I rotate a circle around that line and just keep rotating it around? What do we think? What do you guys think in your head right now that that's going to be? Why not just yell it out loud while you're at home or wherever you are watching the video? Let's see what we got here. Rotating that cylinder. I'm rotating the circle, excuse me. All right, here we go. Rotate it, rotating it around that line, and it ends up what we call in three-dimensional space a sphere. All right, so when I rotate a circle around a fixed line, it becomes a sphere. Okay, a sphere. All right, so cone, cylinder, sphere, those are the ones you're going to have to worry about because now we got some Regents level questions to do together that involve rotating it around. All right, so let's see what we got. All right, first one here. We're going to rectangle 6 inches long and 5 inches wide. All right, let's get one of those bad boys out here. Okay, so 6 inches long, 5 inches wide, and it says we are going to continuously rotate it about the longer side. Okay, so the longer side we know is 6, so I'm going to rotate it around this side right there. And what am I going to end up with? Well, when we did this before, on the previous one, we know we're going to end up with a cylinder. All right, so I can automatically get rid of 2 and 1. The question is now, what's the radius of this cylinder going to be? Is it going to be the 5 short side, or is it going to be the longer side of 6? All right, so as I continuously rotate it around, let's go back to the example I had with rotating the rectangle around. Okay, so we're going to rotate it around the longer side right now. So this is what we're doing. There's the side of 6. There's the side of 5 for us. Okay, so here's the side of 5. Here's the side of 6. Let's rotate it around the side of 6. And do we see what the radius is becoming right here? Everyone see the radius right there? And if you go back, that was our shorter side. We can see it right here. Okay, that was our shorter side. So the radius is actually the shorter side when I start rotating around the longer side. So for our case here, we're going to have a radius of 5 because that was the shorter side. All right, so when I rotated around the side of 6, the radius was going to be 5. All right, this one right here, a quarter circle now, so not a full circle. I'm going to rotate it around the y-axis now. Okay, so when I rotate it around the y-axis, if you start visualizing this in your head, I'm not going to get a full circle here. So I'm not going to get a full sphere. What I'm going to get is half a sphere down below the x-axis right here. Okay, so I'm going to start getting a, what is that? That's embarrassing. That's what that is. I'm going to start getting a half a sphere, which we call a hemisphere, as I rotate it around the quarter circle. All right, if I had a full circle, sure, I'd have a sphere, but since it's just a quarter one here, rotating around, I'm going to have a hemisphere. All right, and then I believe we got one more. All right, I got a square now that has a side length of 7. And we're going to rotate it continuously around side AT. Okay, so rotate it around side AT. And we're told that one side 7, as we know for a square, all sides will be 7 then. What am I going to end up with? All right, well, going back again, when we did the rectangle, which could also easily be a square, it ended up being a cylinder, right? So we can get the cone out of there. Now the question is it going to have a diameter of 7 or a radius of 7? So let's go back and take a look visually here. Okay, so let's see if I can do this. Yeah, buddy. So let's all say you got 7, 7. All right, and as I start rotating this, you'll see, go back a little bit right there. You see how the radius right now of this cylinder, the radius is still the same as the side length of the square, which is 7. So the diameter would be another 7, 14. So the radius will just stay 7 there. As you can see, look, take a look here, guys, right there. That radius is 7. Okay? So going back, we have a radius of 7. Okay? All right, so I think you guys have enough right now to try the homework out. I'm just looking at it right now myself. Answers are up on Aspen. You don't have to worry about putting it in your share folder. Just bring it next time whenever we end up meeting face to face. But please do check your answers up on Aspen. I'm just looking at the packet work right now, number 1. Make sure you come out with your rhombus properties. All right, make sure you know some properties of your rhombus. That'll help you out with number 1. Okay. And remember, when you rotate, it's still a rigid motion, which means angle measure is still preserved and distance is still preserved. All right. Good luck on that assignment, guys. Hopefully, I'll see some of you guys in the meet coming.